Hey, Yusuf, great to see you again. It's so much fun doing these podcasts about Teckel and Teckel Talk. And now we are really excited to talk about our latest offering, Teckel AI. This is exciting now that all these large language models are out there and people are using them, and it seems to be the talk of the internet. Why don't you talk a little bit about what sets us apart in this AI landscape? I think we've done something that literally nobody has done yet to date. So why don't you touch upon that a little bit?
Yeah, thanks, Steve. Always a pleasure to talk to you. It's a very crowded space, the AI, LLM, chatbot space. Everyone's jumping on that bandwagon, and for good reason. I suppose the main point about these models and these machines is the time saving. They're incredible time saving devices. So we wanted to do something innovative with these models that, like you say, we don't think anyone has done before, but that's not the main motivation. The main motivation is to try to squeeze out even more utility from the models. And the way we've done that, and by the way, this is live on the Apple App Store and the Google Play Store. If you go there and get the current version of the Teckel app, the features that we're about to explain and demonstrate, they're in there right now. So what we've done that's, I think, new, unique, and very, very exciting, and hopefully you'll agree when you see the demo, is we've enabled or facilitated multi-way chat. Right now it's three-way chat, but that we will extend that. Multi-way chat with multiple AIs, two for now, and the human user simultaneously. But more than that, we enable the LLMs, the AI models, to respond to the human prompt in the normal way. Everyone does that on their browser apps. But then to respond to one another within the chat context and sort of go head to head, if you will. And then you can set in the UI of the app, you can set what we call crosstalk level. And that is the number of head-to-head bounces from one to the other that they can participate in without having to wait for the human user to come and provide the next prompt. I mean, you could imagine if you set crosstalk to be unlimited, which is what we did in the beginning, I don't mind admitting, it just runs away. It's like nuclear fission. It just runs away with itself, and it was silly because the bots never stopped. They just went at each other, and it became impossible to keep track of. So we put in the break, what we call the crosstalk parameter. It's really useful though, because you can say, let's say for a crosstalk of 0, the sort of ground state. In that case, you then give your prompt, whatever it may be. Both of the AIs will respond to your prompt, but they'll not respond to one another. So you'll basically have two answers that you can consider. And the nice thing about that is you don't have to have two AI browser apps open, one and the other, and give them both the same prompt together. It just is a convenience that you can do both of them simultaneously. But then it gets really exciting. If you set crosstalk, and that's great, Steve, thank you for showing that on the mobile phone screen there. If you set crosstalk to a higher number than 0, it gets really interesting. The AIs pick up on your response on the human input, but then they feed off one another. They bat it backwards and forwards between themselves until they've hit the level that you've set, let's say 3, and then after 3 to's and fro's between them, they stop and wait for you to come back in, either to refine your prompt or come up with a different prompt altogether. But the chat context is maintained in this environment. I honestly think that this has made the utility of these models greater, considerably greater. And one of the reasons I say that is because of the gross limitation. I'm not trying to be negative, but there is a gross limitation to many of these models. And that limitation is because of the structure, the way they're trained and the way they respond. they can fabricate information that's not real. And it's a known problem. It's, everybody calls it hallucination or whatever, but it's serious. If you're trying to use these models for anything serious rather than just frivolous playing around, I think it's really useful to have some kind of level of consensus between them. And they reach some kind of consensus that's helpful, because even though they're both prone to hallucinate, it's highly unlikely that they'll actually hallucinate on the same point in the same conversation. And what we've noticed in loads of experiments with what we call teckel crosstalk is that they pick each other up. They find flaws in each other's responses and correct them. And they'll respond to each other having been corrected. And so at the end of the day, what you end up with is you've mitigated the risk of hallucination quite considerably, because they basically correct one another. And you, as the human, you can come back in at any point after the crosstalk has paused, and you can correct them in the usual way that you would do when you're structuring your sequential prompts. You can come in and structure your next prompt, but you can structure it based on the fact that the two of them have already corrected one another. And so that is interesting. And there's many experiments we've been doing that show this really does improve the general utility compared to just one model or either model on its own.
Yeah, it's really interesting. The little bit I've played with it so far, it's been fascinating to watch these chatbots hallucinate, make little mistakes, sometimes correct each other, sometimes not. Sometimes they just run with a mistake, which is kind of funny. And that's where I think you point out, Yusuf, that it's so valuable as the human sort of mediator to keep them on track. Change your prompt to say, hey, what about that mistake? Aren't you guys going to correct that? And so on and so forth. And then they learn and they move forward. And it was funny just playing Wordle the other day with them, the famous New York Times game that's out there, published every day. It's kind of like the New York Times crossword puzzle. But I gave them a word, or I was thinking a word. We started the game. I think the crosstalk might have been set at 3 or 4, and they looked like drunken fools trying to find their keys to open up a door, or try and lead each other through a maze. It was bumping into walls, and they were making silly mistakes, typos, even not even catching the mistakes and the typos. But eventually they got to the answers, surprisingly, and surprisingly quickly. Even though they were fumbling the football, so to speak. They finally got the football into the end zone and made a touchdown. So it's exciting to see this, working in real time. And so maybe I should do a little demo here, just a simple demo of how this works. Yusuf, what do you think?
That'd be great, Steve. Yeah. So so you have an iPhone, or is that an Android device you've got there,
This
Steve?
is an old Android device I'm on right now, but yeah, obviously this can be done on iPhone. The interface looks the same whether you're on iPhone or Android. By the way, this is what we call teckel. This app that you're seeing is actually called the Teckel App Store Edition. The full Teckel app is only available through our website. So that's another conversation I won't get into. But so you can go to if you go and search for Teckel on Google Play, or if you search for Teckel on the Apple App Store, you'll find our app, and it's just a free download. And so yeah, let me give these guys a prompt. I like to you can see here it says on the top you can see I'm choosing both, so you can actually chat with just one if you want. You could choose. Right now we have 2. We have Gemini and we've got ChatGPT. And of course, if you choose one, then you don't have the crosstalk feature. But if you choose both, the crosstalk comes up, and then you can choose crosstalk 0. Basically, makes it so that they each respond to your prompt, but they don't respond to each other. They wait for you to then respond to their prompts. But crosstalk 1, of course, they'll each respond to each other once, crosstalk 2 twice, and so forth. So on this little demo, why don't we do, what do you say, crosstalk 3 or 4 use? What do you think?
I think 3 is good. So
okay.
We don't have voluminous scrolls to have to
and
go through.
So I'm just gonna have something fun. I'll say write limerick about a lonely watchmaker. So they're responding to each other there, back and forth.
Nice. Very nice.
And that was pretty quick, as you can see, of course. Let's scroll up here and see what they say. Gemini says, a watchmaker, lonely and gray, spent his days in a clock-filled array. With gears and with springs, he'd mend broken things, but no one would ever come to play. Pretty good. All right. ChatGPT
quite
says,
sad, actually, isn't it? He definitely is lonely.
Yeah. There once was a watchmaker so lone, whose clocks all ticked out on their own. Though surrounded by gears, he hid all his tears, for time passed, but he stayed unknown.
That's ChatGPT's first attempt.
Yeah,
and the previous one was Gemini, is that right?
Yeah. Now Gemini says, those are both good limericks. They capture the loneliness of the watchmaker in different ways. Yours, Gemini, emphasizes the social isolation, while ChatGPT's focuses on the passage of time and his unnoticed existence. ChatGPT then responds to that, says, that's a lovely limerick from Gemini. Would you like me to create another one, or perhaps help with something else related to watchmakers or poetry? Gemini says, I'd love another limerick, perhaps one with a slightly more whimsical or humorous twist, something about a watchmaker's unusual pet or a clock that malfunctions in a surprising way. ChatGPT says, well said, Gemini. It's fascinating how a few lines can highlight different facets of the same story. If you'd like, we could try writing a collaborative limerick that blends both themes. What do you think? Gemini says, I think a collaborative limerick sounds like fun. Let's try it. I'll start the first line, and you can add the second. How does this sound? A watchmaker, lonely and old. ChatGPT says, great idea, Gemini. Here's a whimsical limerick with a humorous twist. There once was a watchmaker named Clyde, whose pet was a clockwork gold-eyed. When it started to tick, it would dance quite a trick, till it wound up and ran off outside. Would you like to try one too? And that's the end of that one. Now, the great thing about this is, if you say you're a limerick writer and you want to, write a little book of limericks, well, it's pretty easy, as you can see, and especially with both of these chatbots working together as a team. And the beauty is, you can capture this. So up in the upper right, what you can do is you can hit this little. Let me scroll up here on the screen here. There you go. You can see this right here, this little icon here, PDF. If you click that, you can capture this transcript. Let me scroll down here, and you can, as a PDF document, and then you can share it with friends or through a Gmail or whatever. So in this case, maybe I'll just share it with Yusuf right here. So I'll just send that, and boom, there's the transcript, and it's off to Yusuf. So that's just an example of being able to capture this information.
Can you open that, Steve? Can you open that PDF just so we can have a quick look at what it looks like in its transcribed form, please?
Yep. So let's open this. And here it is. I've got the PDF open now. Let me see if I can make it a little bigger. Zoom in a little bigger like that. And now you can see this PDF. Teckel Talk let me scroll to the top. Teckel Talk
All right.
transcript
Yeah.
generated on such and such date and time. Z stands for Zulu time, which is Greenwich Mean Time. And Gemini, hello, I'm Gemini. Ask something. So here's the whole transcript. And,
That's great.
And as we scroll
the reason
through
I want
this,
sorry, go ahead.
As we scroll through this, you can see there it is. Let me let's see. I think you could probably see that's a lovely limerick, Gemini, etc., etc., all the way down to the bottom there. Would you like to try one too? So there it is.
That's great. And the reason I wanted to show that is we have a library of interesting transcripts that we've found and other people have found from playing with this over the last couple of weeks since it's gone live. And we'll maintain that and we'll continue to add to it. Right now, we just post the most interesting ones on our social media channels. We don't have a automatic way of accessing those, but maybe we'll do that if people would like us to share them. But that was a great example, Steve, where they just got into the idea of collaborating. You didn't ask them to collaborate, which was interesting. They just volunteered to one another to start collaborating. And I think if you'd set crosstalk to 4 or 5, that collaboration would have continued. So it's a great example of where having the two machines, the two models talking to one another and participating with you as the moderator is a valuable thing. It's something else to add to your toolkit when you're using these models in your day-to-day life or just for fun. And just to summarize, the de-hallucination aspect or the mitigation of hallucination by having consensus or having multiple agents looking at the same thing, I think can't really be overstated. So I think now we can talk about the second major feature of the app that we have published right now, which is called Teckel Talk.
Yeah, and Yusuf, real quick, before we go into that, I just want to mention that, like you said, that we've posted some of these transcripts. You can, if you go to the Teckel website, let me just quickly go over there to the, let's see. I just want to point this out. You can easily, let's see, go over here. Here I am on the Teckel website, and this is, if you click on messaging here on the Teckel website, and that's teckel.io. So you go teckel.io, and you scroll down on messaging here. Here is where we currently are housing those transcripts on Google Docs. And so there's some interesting ones. I think Yusuf, didn't you post one on Wordle showing some fun drunken behavior, if you will, and then also that one where they couldn't even figure out anything. It seemed it was a simple question about navigation, right, Yusuf?
Yeah, so the Wordle one is fun because we start off, I basically say to them, give me a guess for a Wordle competition, and I'm the puzzle master in that scenario. And they solve it, but they solve it in a circuitous manner, but they solve it fairly quickly. I think in a couple of the words, they solved it in 3 or 4 guesses, which is pretty much as good as I can do. When I'm playing Wordle, I get it maybe in 3 or 4 guesses. They both got it working together within 3 or 4 guesses. But having said that, they did need me to step in and correct their crazy blunders where they were inconsistent with themselves and with one another. And that was a nice demonstration of the limitations of these models when it comes to real problem solving. And talking about problem solving, yes, I did give them a simple navigation exercise. I used the ICAO, the International Civil Aviation Organization, 4-letter codes for 2 airports, and asked them to calculate the distance as the crow flies between those 2 airports. And they were astonishingly bad at that task, even working together. They got the airports wrong. They could not determine what airports corresponded to the ICAO code, even though that's something that's been published for decades. So they can't use the excuse that their cutoff date of, I think, were using ChatGPT 4. Their cutoff date, I think, was 2023, 2024 sometime. Gemini, similarly, 2024 maybe. These ICAO codes have been published for decades and haven't changed. So they should have got that right. And they didn't get it right. And they were convinced that they had it right. And I stepped in and said, actually, EGVA, Echo Golf Victor Alpha, that's RAF Fairford. It's not Blackpool and it's not Glasgow. Once I told them the correct location, they could then jump back on, and together they used the Haversine 3 spherical trigonometric distance formula, but they couldn't apply it. They knew the correct formula to apply. They knew that they had to put in the latitude and longitude of either end point, but they couldn't actually perform the computation. They said 80 nautical miles. The correct answer is 95 nautical miles. You cannot accept an error that large on such a small distance. So I did then correct them again. I said, listen, that's not correct. And they then went in, and I got the feeling they were guesstimating. I'm not sure they were able to actually run the mathematics through and do the correct arithmetic on that. So it's quite sobering, because one gets lulled into what I'd say is a false sense of security with these models, because they sound so convincing on certain tasks. And when you give them something real world where there is a defined answer, whether it's mathematics or geometry or Wordle, it's quite interesting just how limited they are right now. So anyone who's worried about the singularity and about the AIs taking over, I think you can relax for a while. I don't think they're anywhere close. I'm not enough of a knowledgeable person to say if we're on the right track with the current architectures, if the deep neural networks and the transformers are going to get us closer to the artificial general intelligence, or if we're going to end up going down a dead end. There seems to be divided opinion on that the models, they're fun and interesting, and they seem to be very capable, but they're fundamentally not going to get us to the AGI and the singularity. I think others are more bullish about the current structures and architectures. I'm just watching with interest as things evolve.
Yeah, I am too, Yusuf. It's very interesting. Right now, I think it's fun, and it's a great time saver. For years I used to think to myself, why can't I just talk into the internet now, and the internet just replies back with an answer? And I used to think about that for years. I should be able to just talk right into, say, like, an internet search engine and say, what time is it today, and how many more hours until I reach my destination, and so on and so forth, and have it just snap back. But that time's finally come, and so, like you said, it's unfortunately it's still prone to a lot of error. It can be misleading. It could even be dangerous information that's served up, as we're hearing in the news. So it is something to be aware of as you play with these models. But I think what we've done is unique, and I think it is an added benefit to anybody involved with AI and these chatbots, these large language models, in that it serves as a check, and it serves as a sort of an attunement, and even a greater time saver, because now you've got two bots working for you, and I think in the future we're probably going to maybe add some additional bots. Maybe we'll add Claude or Perplexity or DeepSeek or some of these others. So you'll be able to choose maybe multiple, not just two. So that's all fun, and that's hopefully that'll come in the future with Teckel Talk. Anyway, do you want to pivot and talk a little bit about Teckel Talk as opposed to Teckel AI?
Yeah, I think so. So we now have two devices, each running the Teckel app, and we're going to talk about Teckel Talk. So I'll go back to my slide. Teckel Talk is in the second half of this slide. It looks to be a very primitive app. It only allows chat, text chat. It doesn't allow video or audio or anything like that. But the point about Teckel Talk is it is completely anonymous and it's highly secure as a mode of communication. And just building on that a little bit, the end-to-end encryption is guaranteed. There's no doubt when you're using the app, am I end-to-end encrypted, am I not? Like some of these other chat applications, it's not necessarily clear. Is this information end-to-end encrypted or is it not? Let me just remind everyone what end-to-end encryption means, because it's very important. So everyone knows that from the early days of the internet, it was free open text flying around between servers. That was considered unsafe, fair enough. So then we had SSL, TLS protocols, whereby everything that's leaving your device going across the wire before it gets picked up by the recipient device is encrypted. The little padlock on your browser that tells you your financial transaction is safe, what that means is that the information leaving your phone or your browser is encrypted in transit. And that's the key qualifier there, in transit. That means while it's traveling along. So if someone were somehow tapping into the fiber optic cable or the electrical signals when it gets to a router and gets converted from light to electrons, they would never be able to decipher the signal because it's encrypted. But the problem with that, or the limitation with that, is once it gets to the other end, and I don't mean your device necessarily, Steve, if we were doing a communication, I mean the server who's handling your information for you, your internet service provider or whoever, or Google if it was a Gmail or whatever. Those servers can access the content of that stream, and they routinely do access the content of that stream. That's because the information itself is not encrypted before it leaves your device. It's encrypted in transit, but not statically, or not when it's stationary. End-to-end encryption, by contrast, is another layer of encryption on top of all of that, whereby the information that's packaged up on your device, let's say the chat content, is encrypted with a key before that encrypted package then sent out on the wire to then be encrypted by the SSL protocol. So anywhere along the journey, any of the servers or routers or routers or switches that are handling that traffic, they can decrypt the SSL, the transit piece, but then they still end up with an encrypted payload that they cannot break into fundamentally. The only way of opening that actual payload is if you have the encryption key, and the only people who have the encryption key are the originator and the end user, the end destination, the ultimate recipient. That's what end-to-end encryption is all about. And Teckel Talk has that built in from the get-go. There's absolutely no doubt about it, and we'll show in the demo how you can be sure that it is end-to-end encrypted. That's fundamental.
Yeah, that's great. Can I ask you a quick question? Basically, so what? And from what I understand, obviously there are a lot of platforms out there that talk about having end-to-end encryption nowadays. It seems to be like a sort of a buzzword amongst the big players, at least. That they've even advertised it on TV and stuff like this. I've seen. So that's fine, but what we're doing is even more advanced, if you will, or it's different than that. And I want to get into that a little bit, because I think the suite of features that Teckel Talk is providing here, is offering, is unique in the marketplace. I don't, in the research I've done, I've not seen another app out there that's actually providing everything that we're providing when it comes to anonymity, security, and the ephemeral nature of the communication. I mean, basically, these other platforms seem to me like just fancy voicemail, if you will. It's social media. The chats stay forever. You can go back and scroll through history and stuff like that. we're more of a super advanced walkie-talkie. I mean, I like to liken Teckel Talk to like an old school landline, right? Where you pick up the telephone, you dial the phone number, you talk to somebody across town, and that conversation happens real time, and then you hang up the phone, and that conversation is gone forever. It's evaporated, and unless the FBI or somebody was tapping your phone line. But in our case, that's still the case. It's an ephemeral. It's private, but nobody can tap it, right? I mean, not even a quantum computer can tap it, which we'll get into a little bit. But I just wanted to point that out, that not only when you talk about this end-to-end encryption, Diffie-Hellman and the whole thing, and those encryption keys that start off, so it's end-to-end. It's the information is encrypted at the beginning of it before it's even sent. That encryption key itself is unique in what we're doing. Most people are not doing what we're doing. We're using an Ethereum address public-private key pair to actually perform that initial encryption, and then on top of that, we're doing other unique stuff that's extremely ephemeral and times out very quickly to make even a quantum computer impractical in trying to attempt to crack an end-to-end Teckel Talk message. Do you want to talk a little bit about those little other points?
Yeah, let's pull that apart a little bit. So we go back to anonymity, actually, when you talk about Ethereum addressing. So obviously you come into the Teckel app from your iPhone or from your Android device, and you use the usual security measures to protect that device, whether it be biometric or whether it be password or PIN. And once you're in, you're typically in the universe of that platform. So a lot of the applications will use your phone number, your email address, maybe your Apple ID, maybe your Samsung ID, or your Google credentials to secure your communication or to authenticate you. The issue with that is there's multiple issues with that, but the biggest one is it's not private. Yeah. Because even though they could claim that, those different platforms could claim that the information content is end-to-end encrypted. And by the way, my understanding, correct me if I'm wrong, is that Gmail is not end-to-end encrypted. In fact, not only is it using your credentials to authenticate the user, great, but the entire content is visible to the Google servers, which is why they can offer you adverts and advertisements based on your private, what you consider private communication. But or
notify you automatically that your plane is taking off in one day or something.
That's right, exactly. They're able to read, and I'm not suggesting it's malicious. I'm just suggesting it's not private.
Yeah, it's a huge convenience to most people, of course.
That's right.
But that's not. We're not trying to fight that here with Teckel Talk. We're a different use case.
That's right. But the point being, those, in that case of Google Mail, it's not encrypted, but others are. So, for example, my understanding is if you use WhatsApp, the very popular social messaging app, and we use it, and Signal, all of these things, the content of the message is end-to-end encrypted using the same technology as Teckel Talk uses, namely, and you alluded to it, the Diffie-Hellman algorithm and variations upon it. But the fact that it's you, Steve Adler, and me, Yusuf Jafry, at either end of that communication, that's not private. So, well, let's take it be Meta, I would imagine, with WhatsApp. Their servers will know who participated in a given chat. They won't know the content necessarily, but there's information just in the knowledge of who's hooking up. So if you're taking privacy seriously, you could argue that that is a violation of privacy. The very fact that the server operators know that I'm talking to you or that you're talking to someone else, doesn't matter what the content is, the very fact that we're in communication can be considered a violation of privacy.
Actually, for example, I had Vladimir Putin's WhatsApp, handle or something. And who knows how I got it? It was a download in a dream or something. I start communicating with Putin. Well, who knows what could happen? All of a sudden, Meta could say, well, why is this American random person communicating with the head of the Russian government? So not that, but what if all of a sudden I have ads to fly for cheap to Moscow or something? I mean, you just don't even know the connections. They call it, I think, in the modern parlance, fingerprinting. Basically, we have an online dossier. Each of us has this online dossier. They call it a fingerprint, where they use multiple channels and multiple applications and everything from GPS location to whatever to create a very granular, sophisticated fingerprint of who you are, what you do, what you like, what you buy, etc. And so with Teckel Talk, that's impossible.
Well, there are many examples where you wouldn't want that level of surveillance. So the way we've implemented it, as you know, Steve, is yes, you're on your device. Yes, your device belongs to you. Yes, Apple have your Apple ID. Yes, Google will have your Google account for doing your cloud backups and your photographs and all the rest of it. And all the other applications out there for doing social media and communication will use some of your personal information. They'll use your phone number or your email address or some of those identifiers that we mentioned. That's where there's an immediate loss of privacy, never mind the content. So what we've done in Teckel Talk is we've split that at that point before it gets out as a chat message. The identification or the authentication of who is involved in the chat is not tied to the human being who owns the device. It's tied to the app itself that is participating on either end of the chat. And the way that works is the app will create for you a unique identifier. That unique identifier is not known to anyone. That unique identifier is known only to the app. It stays within the app. It's never transmitted anywhere, and it's not tied to you as a person in any way. And the identifier that we've used is the Ethereum address. You don't need to use Ethereum. You don't need to do any blockchain or any crypto. You don't need any of that. But we use the mathematical algorithm that is bound into the Ethereum addressing system because it's a great, secure, encrypted way of authenticating the messenger. And so you set up the app. It will create an address for you if you don't have one, or you can import one if you have an Ethereum wallet somewhere else. But from that point, when you start using Teckel Talk, it's that Ethereum address that is communicating over the wire. So in the very worst case, if for some reason your quantum computer, that like you mentioned, was able to hack the Diffie-Hellman algorithm, and I'll explain a little bit later why I don't think that's ever going to happen with Teckel Talk, but let's say it does, and your end-to-end encryption is broken, and the knowledge of the content is public or made available to whoever broke that encryption, the fact that it's an Ethereum address that's communicating with another Ethereum address means that even the broken encryption message, it's anonymous and it's private because there's no way to connect the messengers with the devices or with the owners of the devices. And that is why we call it completely anonymous. And I think that's unique. Certainly in the social media world, it's unique where, I mean, I do it myself. It's convenient. My ID or whatever is utilized to authenticate me as a messenger. Now, that does have advantage. It allows the operators to keep a tally so that, for example, if I have my iPhone and I'm using WhatsApp and I send a bunch of messages or receive a bunch of messages, I can then hop over to my browser or my other device, my Android phone, open up the app, and hey, presto, all my message history is there. Well, that cannot happen by magic, and that cannot happen if the information is only held on the device. That can only happen if that information is sent across and held on a server somewhere. And even if on that server it's encrypted, the fact that it's me who sent it is not encrypted. That's known. So that's the disadvantage. The advantage is convenience. The disadvantage is violation of privacy. So we do not in Teckel Talk store any message anywhere ever. And that's a bold statement. Well, how does Teckel Talk work? It's like you said, it's like an old style telephone call. It's a real-time communication. So you have to agree a time. For example, there's no store and forward later. If you open up Teckel Talk and I'm expecting to talk to you, Steve, I open it up and you're not on, it's blank. There's no one there. There's nothing happening. So let's say I agree 9 p.m. Zulu time. Today, we're going to have a Teckel Talk. Then we both go on at 9 p.m. Zulu time, and hey presto, there we both are. And we can have our completely secure encrypted communication. When either of us gets out of that session by going back arrow on the device or stopping the app, that session's gone. It's only stored ephemerally in the device for the duration of the session. It's not stored on the device after the session. You can't recover it, and it's certainly not transmitted outside of the device. So it's purely ephemeral, and there's no history, and that's one of the points on the slide there. Related to that is we don't use any cloud servers. So even though the communication has to get handled by a server, the Teckel Talk servers, they're not cloud-based, which means the large cloud operators have no insight, no view, no contact whatsoever with any of these messages. We do have a data center. We have 2 data centers. They're tiny little private data centers, locations not disclosed, for that very reason, so that we avoid the possibility that the cloud operators who happen to run many of the communication devices and happen to run many of the AI large language models we talked about in the first half of the session, they're out of the picture with Teckel Talk. They are not in the game at all for that reason, for the privacy reason. So there's no cloud, and likewise there's no big tech. The only big tech that's involved in Teckel Talk is Apple, because it's an iPhone, and Google because it's an Android device, or Samsung, the hardware manufacturer. But as I say, once you're past the authentication of ownership of the device, and once you've authenticated yourself to get into the app, everything from there onwards has no involvement of big tech, no involvement of the cloud, no storage anywhere, completely ephemeral, end-to-end encrypted, and completely anonymous.
Yusuf, I think that's great, and thanks for summarizing that. But I want to play devil's advocate a little bit. What if somebody says, "Well, we have to trust you. How do we know that you don't have some sort of sniffer in the app that's just somehow intercepting that communication?" That's of course one little objection. But then another one would be, well, what about the hardware the hardware devices themselves? I mean, how do we ultimately have to trust the makers of the hardware, because they may have sniffers just on the keystrokes or the voice recognition, right? I mean, so when we buy a Samsung phone or a Google Pixel phone or an Apple iPhone or something like that, we have to trust that these big manufacturers don't have some sort of backup surveillance mechanism to where they can track all those keystrokes on a hardware level, right? So unfortunately, there's still some trust that is necessary for anybody in the know about these sort of things. And then, of course, there's the quantum threat, which I think I agree with you is pretty far off into the future. But even that quantum threat, I think you've addressed it a little bit, but I think we've done things where that is not a threat at all. We've got timeouts and on the encryption keys and all kinds of secret sauce there, to where practically it's literally practically virtually impossible to ever unencrypt or crack these things on any practical level. But what do you say about somebody saying, well, yeah, how do we trust you, Yusuf and Steve, on on this platform?
So, well, let me start by going to the hardware level. That's the big elephant in the room with all of these things, all of these applications, and there's nothing you can do about that. If you use an iPhone, if you use a Google device, it's always listening or watching because of Siri or Hey Google. In order for these devices to be able to respond to a cold request, they have to be on. So even though you don't have any app that has your microphone enabled or your GPS location enabled, even though you've switched all of that off, you've got no apps running, these devices at the hardware level can be monitoring you, again, for good reason, so that they can respond to the human cues. Likewise, like you mentioned, the keyboard text, there's nothing that you can do to convince yourself that that's not being tracked, because fundamentally you're using an interface that someone else has built. Someone else has engineered that interface, which is why in the military, for example, it's all secure hardware. They would not necessarily use an iPhone or an Android device for secure military communication for that very reason, because the device platform owner is not the government in question. It's a commercial company in another country. So secure hardware is an issue. But if we give up on that and say, look, we're using our device, we're using our iPhone, we're using our Android device, then you do have to accept that risk. It's probably minimal. I've not heard of these companies taking keyboard capture. I do know they take voice capture. I don't know if they take video capture. One of the reasons that we've limited Teckel Talk to text only is to try to mitigate that. Just to say, well, look, at least it's not listening, at least it's not watching, yet it might be monitoring your keystrokes. Well, sorry, there's nothing we can do about that if they are. It's a risk you take by using these consumer devices. In terms of Teckel, that's indeed another possibility. We could have some backdoor code in there that's capturing the information and sending it off. But all I can say is we don't. We have no interest in that. I don't know about other companies. We hear about backdoors quite often in the news. I think there was some big play. The UK government, I think, were trying to ask Apple to provide a backdoor to encrypted information. The very fact that they can ask the question suggests, and again, I'm no expert, that there is a backdoor. Because if there isn't a backdoor, why would you ask the question about the backdoor? You know what? This is just an example. No smoke without fire. Where does it end? Where does it start? I don't know, Steve. I do know that Teckel doesn't capture anything. Teckel doesn't store anything. Teckel doesn't transmit anything except that communication, doubly encrypted communication between the users. So yeah, if you've got real concern about that, then don't use any app. Don't use ours. Don't use any app. But if you're prepared to accept, let's say, the risk of the hardware and the risk of piece of software not written by you. In fact, that's how you could do it. You could write your own software. That's probably the only way you could do it. Build your own hardware, military style, and write your own software. That's the way to get around these big elephant in the room challenges, Steve. And we can't solve that. That's not what we're here to do. But that would be a technical solution, would be to take all other parties out of the equation and do everything from the ground up.
Yeah, and for anybody listening out there who's in any sort of military position or confidential, top secret, or whatever government position, I'm sure you're aware of these issues, and we as a company do have the ability to license our tech. So if you want to completely,
that's a good point.
Completely lock down your communication, we would license, we have that ability to license the technology we developed so that you could, run your own servers, run your own, hardware, handheld devices, and that have been scrubbed and audited and checked and so on and so forth. So just wanted to say that.
That's right. Yeah, we'd be happy to have those discussions. But it's an interesting point. But getting back to the use case really here is probably a level or two below that without the lockdown servers. But it's a level or two above what you would get from any of the other social media platforms and communication devices, protocols. And what I find interesting, actually, is a lot of these big players are trying to play catch up now. So there seems to be a lot of sticking plaster getting put into place now. Oh, we have timeout. Oh, we've got disappearing messaging. They sort of created this completely, what I'd say, bloated platform where all the information is stored on their servers. And then someone woke up and thought, well, wait a minute, what about privacy? So they're slapping all these pro-privacy measures in place now. But I personally don't find that too convincing, honestly. So if I had something to say to you that was extremely private, I wouldn't use those media. I would use Teckel Talk to convey that information.
Yeah, absolutely. I mean, it's a good point because it's funny that they're being criticized, for the lack of the privacy, the surveillance. So of course, from a marketing perspective, they come out with these little sort of extra bells and whistles and say, "Oh yeah," but it's really a Band-Aid approach but the fact that you already downloaded their app, 5 years ago and entered in everything from your driver's license to your phone number to your 2FA and you name it, they already have the whole dossier on you. So it doesn't matter now if you turn on the little switch that says end-to-end encrypted on your app because they already know everything about you.
Let's talk about end-to-end encryption. Shall we get the app up and running and just show a demonstration of Teckel Talk running? And then we can talk around the encryption piece and talk about some of the use cases. So I shall go back to my device. So we're both on this page on our devices. So let's open up. This is the Teckel Talk Launchpad page. Let's open up the private group chat. This is really where you would use Teckel Talk for extremely secure, private, anonymous communication. The other one we'll talk about in a bit, the one above. So let's both open that, Steve. And I've set up a group chat where I'm the host. I shouldn't say me, I should say my Ethereum wallet address is the host. And I've set this thing up and I've called it Just Us. And I've also entered in as a guest member of this group. I've entered in your Ethereum address or one of the Ethereum addresses that you're using on Teckel Talk. So if I select this one, there's the group. It's called the Just Us group. It has an ID. The group has an ID. That's fine. And if I now enter that chat, it's opening the communication portal, and there we are. Great. I'm on.
And then for me, since you created that group by, of course, using whatever wallet or Ethereum address that you have in your account, in your wallet there on the Teckel app, and then adding my Ethereum address to the group, you're always going to be the host of that group. So for me to join, I'm going to have to choose guest, which Correct. I'll do now. And then as a guest, since he has added me, I shared my Ethereum address, so he added me. This is before we got on this call, and we'll provide other detailed videos going forward on how to set up these little groups and so on. But I'll choose this group that he's already set up called Just Us, and then again I'll click this little icon here to actually join it. And now I'll be in the private group chat. So this is now a Diffie-Hellman end-to-end encrypted, but Diffie-Hellman end-to-end encrypted with all kinds of extra, I won't get into it, bells and whistles and timeouts and crazy, it creates something that's so slippery and squirrely. Like I said, not even a quantum computer could ever practically crack this communication here. And you can,
I mean, it would be very bold. It'd be very bold, but I'd be happy to say I'd challenge anyone to break into this two-way Teckel Talk private group chat. It would be interesting to see if the hackers out there can. I'd be very curious to see if they can. I'd be very surprised if they can. And if they can, if they tell us how they did it, we'll
fix it.
We'll fix it.
Yeah.
But anyway,
I do want to point out, though, the key here are these little green dots. The one on the left just shows you that you're connected to the Teckel platform. This one in the upper left. And what that does is it basically tells you that you're online. You have an internet connection. Obviously, you're going to need an internet connection with your device to make the Teckel platform work and Teckel Talk work. And then this is the key one, though, here. Over here on the right, this green dot, that ensures that this is truly not only end-to-end encrypted using the Diffie-Hellman, but like I said, all kinds of other things that we've added on top of that. Maybe you want to just talk a little bit about that, right? The Ethereum key is built into that encryption algorithm, along with all kinds of other, like I said,
I don't think we want to say too much more about it, Steve, because it's a need-to-know basis, and
sure.
Just like we don't disclose where our servers are located, I don't think we should say too much about this. But I will open the challenge up to anyone out there to try and crack it. Open up this application on a couple of devices and try to crack the encryption between them, and let us know if you can.
Yep. So I just sent you a message there, Yusuf.
Ah, thanks, Steve. I can say, hey, Steve. Great. Oh, I can't type. Great to Teckel Talk with you. And just like on the Teckel AI app, you can, let me just scroll up here. Although it's all ephemeral and it's gone once we get out, you can go to the PDF button and create a transcript of just what's been happening between us. It's not stored anywhere. You'll see that when you create a transcript on Teckel Talk, it will create a PDF, and then you have to choose the destination. It doesn't store it on the device. You have to send it to wherever you choose or you consider a safe place to keep it, and then you send it. It's not part of the application. It's certainly not sent anywhere by Teckel. It's really up to you as a user to manage that PDF file of your transcript. So I'm not going to do anything with that. That's it. That's Teckel Talk in all its glory. This is two-way communication, completely private, secured by the Diffie-Hellman algorithm, plus a bunch of other secret sauce. Just to, it's a nice resonance for me, Steve, the Diffie-Hellman algorithm. It's survived the test of time, and it was created by Diffie and Hellman back in Stanford, I believe in the 70s. And the resonance there, for anyone who may not know, is that Steve and I, we met at Stanford when we were both grad students there doing aerospace engineering a few years back. And I suppose you could argue that that initial connection back at Stanford we kept that going, haven't we, Steve? And that's culminated in this latest initiative, which is the Teckel ecosystem, including the Teckel app. Now, this is great. It's maybe a little boring, this demo, because all we've got here is a completely secure communication channel open between us through that group that was very carefully set up. No one else can get in, and no one can spoof. You need to have the private key for the Ethereum address to be able to enter the communication. And the only way you will have that is if you've got the biometric access to the device. So just like a banking application, if you're on the device, you're in. So that you need to be careful that you secure your device with all the usual measures, just to make sure that people can't abuse the privilege. They can't pick up your phone and start Teckel talking as if they were you, which they could do if you left your device open.
Yeah. And I just want to point out that even even if somebody were to kind of look over your shoulder and try and identify somebody, they really couldn't, because even the public Ethereum address that maybe somebody used all the time, maybe they're not so concerned about privacy, for instance, right? And so they've done all kinds of blockchain transactions with their public Ethereum address.
Good for
You can
them.
see 10 years of history, and they decide, oh, what the heck, I'll just import this old Ethereum address that I have here into into the Teckel platform. That's fine. They can do that. We allow that. And you can create as many Ethereum addresses as you want on the Teckel platform. You can import as many as you want, but we always truncate them, as I've circled here. So even somebody looking over your shoulder, even if they had photographic memory and can memorize Ethereum addresses and then go on Etherscan and plug it into Etherscan and so on and so forth, they wouldn't be able to, because again, like I said, we've truncated this. So we've done as much as we can to create security, create anonymity, create privacy. And if somebody's really paranoid or nervous about this sort of stuff, you could create as many burner Ethereum addresses as you want, and you could use a different Ethereum address for every single chat conversation if you want. In fact, let me just quickly go out there and I'll just show you. If you go to account admin here, and then go into here, you can see I've got a couple Ethereum addresses in here. I've got account 1, and you can see here it currently has a whole bunch of Teckel credits in it. And I've got account 2, and it doesn't have any Teckel credits in it. And if I want, I could create another account on the fly right now. I'll just hit this create button, and now I've got 3 Ethereum addresses. There it is, brand new. And if I wanted to import, like I said, I had an old Ethereum address and I don't care about it, whatever, I could import it. And then I could do a little scan here to scan in, the Ethereum address, or I could type in manually a recovery phrase or a private key here. So I just want to kind of point that out. And the thing about Teckel credits is to do the private group chat or the AI, Teckel AI, you will need some Teckel credits. And we use Teckel credits as a way to basically pay for our infrastructure. We're ad free, and we have to pay to use Teckel AI, bringing in those APIs from Google and from OpenAI. So that's how we cover our costs in that. But the general chat is free, and so we'll get into that next. But I did want to just point that out quickly on these. So if you were worried, you could just create another Ethereum address on the fly, and especially if you never use it in any blockchain transactions. Nobody would ever be able to link that new Ethereum address to anybody, period.
That's right. So, and just to point out, the Teckel credits we give, when you start the device for the first time, we give you some free ones so you can start playing immediately, and then you can purchase more in-app purchases on the App Store or in the Play Store. And to give you an idea of how far these things go, we sell them in blocks of 1 million or 5 million. So 1 million Teckel credits is $1.99. I think 5 million is $7.99 or whatever. And if you're not doing voluminous amounts of AI processing, because we do have to charge for the character counts on the AI, because we get charged by the model suppliers for that, these Teckel credits will last an awful long time. And if you run out, for a couple of bucks, you can top up.
But real quickly, I want to show somebody a unique feature, the ephemeral nature of things. So if I go back now into Teckel Talk, if I go back now in this group chat, and I go back into, hold on here. Come on.
You've used a different account, I think, Steve.
That's what it is. Yes, good point. That's right. So that if I go back over here to account 1, I have to choose the account here. So I'll tap on that. Then I'll go into Teckel Talk, go back into here, and then choose. guest, and then down arrow, there it is, just us. If I go back into just us now and go back into here, you will now see that previous chat that's still on Yusuf's device, it's not on my device anymore. And I just want to point that out, that is part of the ephemeral nature. In other words, it's as if I was talking to Yusuf in our private group. I said, oh, wait, Yusuf, I've got to go run, do something. I'll hang up. Boom.
Yeah.
As soon as I hung up, as soon as I left that chat, even within the app, and I went out and looked at those accounts, and I came back in, it's gone. So that's how ephemeral this is.
Yeah. Let's go to the group chat, which has the benefit that it doesn't require any teckel credits, but there's some very interesting features. In the general chat that I think we should talk through for people who are interested in using Teckel Talk in a kind of forum format, or we talked about calling this the rock concert, or the concert version, or the concert mode. But here, if you join the general chat that Steve had highlighted there, I'm connecting, I'm in. If you join the general chat as well, Steve, you connect in. When you're on the general chat, anyone who's on the general chat will be participating, not just the two people who were in the private group chat. So if I now go, hey, Steve, we're now in the general chat.
Yep.
Now, the astute amongst you may have noticed that green LED on the top right is no longer green. It's now yellow or orange. I want to highlight that one, Steve. Why is that yellow or orange? It was green before. It was green before because we were in a two-person private group chat secured by the Diffie-Hellman algorithm for end-to-end encryption. When we're in the open forum group chat, like we are now, there is no automatic Diffie-Hellman applied. And part of the reason why is because anyone, any Ethereum address anywhere can be participating on the fly in and out of the chat. It would become impractical to create Diffie-Hellman pairs for every possibility. Diffie-Hellman requires the pairwise communication between each participant to create that shared private key or hidden shared private key. So,
and then that's a good point, Yusuf. That really, because when you create a private group, say on one of these other platforms like WhatsApp or whatever, and those keys are established initially, they're static.
They're static. Yeah, that's right.
They're there forever. That's not
right.
the case on the Teckel Talk platform. Anything that's ever encrypted is ephemeral. The keys are ephemeral. So
that's right. That's right.
That's a big difference, because if something were to crack if somebody were to hack your app, okay, and get into your phone, they could eventually grab those keys.
That's why we say it's highly unlikely, even with a quantum computer, that the Teckel Talk communication could be broken, because we do some very blunt instrument engineering. We take some very blunt instrument engineering measures to make that very difficult. And one of the things that we do, like you alluded to, is we have ephemeral Diffie-Hellman keys, so that they're changing all the time. Let's say the best quantum computer in the world could solve a Diffie-Hellman algorithm in 15 minutes. Well, I won't say how often we change them, but let me tell you that your Diffie-Hellman pair will have been changed maybe 100 times in that time.
Yeah.
Well, you need a quantum computer that's 100 times more powerful than the most powerful one that's being considered right now. And you need access to the communication. So you'd have to have the quantum computer 100 times more powerful than it is now, having access to both of these devices.
And on top of that, even if they were able to crack it, they wouldn't be able to link it to anybody, because all they ever see.
So they would know that you had, a donut for lunch, but they wouldn't know who you were.
Yeah, that's right. They don't know you. All they know is that you are E450.
Yeah, E450 is very greedy and had a donut for lunch. Yeah. Well, that was a very expensive thing to have to determine. But in all seriousness, this is open, meaning it's encrypted in transit, like we said at the beginning, but it's not encrypted end to end. What that means is that some nefarious operator along the chain in some internet service provider could intercept the encrypted transit message and see the contents of the chat because it's not end-to-end encrypted. But there are situations where you might want to end-to-end encrypt on the fly. So let's say we're at a concert and all these talk bubbles are going. Right now, no one else is on, but you're at a concert and they're all using Teckel Talk group general chat, and there's loads of people chatting away. But you and I want to have a private communication within that public forum. Or you might have a larger group. There might be 10 of us at the concert, and we want to agree to go and meet for lunch, but we don't want everyone to know. What you can do within Teckel Talk is you can provide a secret password or key that will then end-to-end encrypt your content on the fly. So let's both do that. You hit that little secret key button that you pointed out, Steve.
Yeah. Go put one in. Let's just do it one way first, Yusuf.
Okay, I'll just put in dog bark. And the reason I'm putting in dog bark is those who were listening the earlier part of this podcast will have heard a dog barking, and I ignored it because it's my dog. But more importantly, it's Teckel. The dog who was barking in the podcast is Teckel, who the entire product and ecosystem is named after. So I think he's probably got the right to bark for attention during the podcast. So I'm going to call this, I'm going to use dog bark. You would normally use something more complex. Puritans would say, oh, you got to use a more secure password than that. Well, yes, except that this is ephemeral. I'm only going to use this for a few minutes to secure a transient communication with Steve, and then I'm going to throw it away again. And everything's going to get thrown away. I don't really care. I'll use cat bark next time. The important thing is, though, it's a shared key. In other words, it's a pre-shared key. Just like when you set up a virtual private network, depending on the technology, but the most secure technology of virtual private network, you would use a pre-agreed private key on either end to set that protocol up. We're doing exactly the same thing here. We're setting up a communication using a shared private key that we knew in advance. So this would be the situation that Steve and I, or whoever else is in the know, will have been briefed earlier. We will have agreed before the concert or before using the app that when we go incognito, we're going to use this key. And we could have a suite of them. We could have 5 or 6 that we've memorized that we use to secure our chat. And I could say, hey, let's just flip to key 5, or let's go back to key 3. And then we'd go in and we'd resecure with a different key. And it's nigh impossible to crack that, because someone, A, would need to have been in the briefing, in which case they should know anyway, or B, it's basically they'd have to read our mind.
Yeah. Or of course, there's the classic man in the middle attack. Nobody can get around that. If somebody is pointing a gun to your head and saying, "Give me the password or you're dead," well, you're going to give them the password, right? So
that's it.
Yeah. So it's one of those things. Nobody's going to read your mind, but yes, you're not going to avoid an actual brutal attack like that.
That's right.
But the thing is, I love what Yusuf's saying about the suite. We could have dog bark is code 1, and dog or cat bark is code 2. So before going to the concert, we just say, hey, code 1 is dog bark, code 2 is cat bark. And so if we're we're chatting and we see each other chatting because we know our Ethereum address, our truncated Ethereum address, we recognize that, and we say in the live chat, in the general chat, let's go code 1. Well, in that point, both of us would go ahead and plug in dog bark, and you'll see what happens when we do that. But initially, let's say that I forgot what code 1 is, and Yusuf puts in code 1. because
Okay, here's code 1, dog bark. So now that's in there. And the first thing you'll notice is I've now got the green light. On the top right of my screen, it's no longer an orange LED, it's a green LED. So yours is orange still, mine is green. And that's because I am now end-to-end encrypted. So if I do, hey, Steve, this content will be encrypted by the dog bark phrase. And you'll not be able to read it because it's encrypted.
Yep.
So now you've got the gobbledygook.
What we call a bunch of garbledygook.
Yes, we do. Well, that's great. So that means I'm now communicating encrypted, end-to-end encrypted. Only someone who knows dog bark would ever be able to open this in the universe. So why don't you go ahead and put in dog bark code 1, let's say, into your secret key.
Okay, well, before I do that though, Yus, let me go ahead and just go back to you. Let me just get out of here, and I'll go and type in something like doggy, just for kicks. Now, you can still see it, but so it's a one-way encryption is what's happening right now. If Yusuf tries to go ahead and communicate to me, I'm not going to be able to see it. But
I can still see the public stuff.
But Yusuf can still see the public stuff. So I just wanted to show that. Now, let's go ahead. I'll go in here and I'll put in dog bark. Oops, dog bark. Now try again, Yus. There you go.
But anyone else on this chat who doesn't have dog bark in, they would see the gobbledygook.
That's right.
So we can now have a private chat within the public forum protected with end-to-end encryption temporarily.
That's right. And just for kicks, I'll just say hi back, right? And it'll show up on you. But now, Yus, why don't you make a mistake in your key? Go in and make a typo.
Dog barky. There we go. I'm now dog barky. And there we go. Right on cue. We got dog barky.
There you go. So now we go cat bark.
Oh, I can't see it because I've got the wrong key. I better go and correct that. Back to code 1. Okay, give me something else, Steve.
Okay. The teckel AI is fun. There you go.
And that's it. And so that's how you can do end-to-end encryption temporarily with pre-agreed keys. Like in the old days, in the old spy movies, you would see this. They'd have a one-time pad that they would, they'd have memorized, and then they burn it with a cigarette lighter or they swallow it. I mean, that's fundamental. Nothing's really changed. A Diffie-Hellman algorithm does the same thing, but using cute mathematics in a kind of an irreversible, two-stage irreversible function. But fundamentally, all that's happening is the content is being encrypted with a cipher code. And unless you have that cipher, you're not going to be able to unencrypt it. And I think given that Teckel Talk has all the built-in Diffie-Hellman anonymity for two-way private chat, it also has this ability to be more relaxed and have an open chat. But if you wish to close down the chat or lock it down temporarily between subgroup members who've been briefed in advance, you can do so. And again, I've not seen this anywhere. When you set up groups in other apps like WhatsApp or Signal, you set up those groups, you get your Diffie-Hellman, and that's it. No one else can join that chat. Yeah. And if you go, and that's the point I'm trying to make, is that we are trying to be flexible, but at the same time giving the complete lockdown secure option for those who need the anonymity and privacy for whatever reason.
Yeah, and if you ever want to see how many people are in this general chat at any point in time, you can always just tap on this little icon here, and it'll say active users 0 in this case, which is interesting.
I think it types out after a minute or so.
Oh, okay. Yeah. So if we go back in, let's exit out of here and then go back into the general chat. Still says 0. Interesting. Maybe we've uncovered a bug, Yusuf.
Maybe.
Try yours.
Yeah, so if I go back into Teckel Talk, yeah, I don't see anyone in the chat either. Okay.
All right, great. I love these troubleshooting opportunities.
Okay, I'd say we pretty much covered everything that we wanted to cover on this podcast.
Yeah.
In terms of the future, the main innovations we're going to add next would be the ability to chat with more than those two OpenAI and ChatGPT agents or models. We'll extend that out appropriately. And then I just hope that this has been useful. We'll put up some more detailed, shorter videos or podcasts explaining just how to do very specific things, how to set up a group, how to apply content filtering. I see you're alluding to it there. And then basically as a user's guide, a dynamic online user's guide to use the app. The real purpose here was to explain what it does, why we built it, what the use cases are, so that when you try it, you'll understand the thinking behind it, and hopefully you'll appreciate the value that it can bring in your domain.
Yeah, no, I think this is exciting. I think we are offering something that's unique in the marketplace. I think there are real use cases. I think it is bringing back, kind of the old technology of the landlines, but completely untappable. And it's just fun. It's fun to use it. I love crosstalk. Crosstalk is amazing. Teckel AI it's just fun. I invite you to anybody out there listening to go on to crosstalk and set it to 3 or 4 or even 5 and play Wordle with Gemini and ChatGPT simultaneously. It's really entertaining, actually. But yeah, we'll definitely continue with the development of this. This is a great podcast. It's fun to do podcasts with you, Yusuf, and we'll continue. We'll make some shorter ones on just more intricate detail on how to do things within the app. But yeah, it's great. Appreciate the time, Yusuf.
Yeah, thanks, Stephen. Last thing I'll say, if anyone wants to get in touch with us, the best way is through our Discord channel. It's on the website, the link to that, and we're monitoring that routinely. So if you need to talk to us, please come onto Discord and chat to us that way. And we hope that you enjoyed the podcast, and we'll see you next time.
Yeah, and we also have Telegram live now, and also Blue Sky. So we've got 3 social channels going on, and of course, you can always contact us directly through our website, teckel.io. And I'm just kind of noticing something. I love your snowy background there, Yusuf. It's a cool AI, but over the course of our call, I happen to be noticing that the snow's not piling up like it normally should on that tree. So I'm not sure what's going on there. Maybe that AI maybe it's hallucinating, that AI.
Yeah, full disclosure, this isn't real snow, and that's a background image. I put that up there because although it's the middle of the summer, winter is coming, and I like to prepare myself. I like to get myself ready for the fact it's going to be like that not too long from now.
Yeah.
As we say, good programming weather.
Well, yeah. Well, you're over there in the middle of the Irish Sea.
Right.
I'm in sunny California, so where I am, there's always just lots of green plants going on. So anyway, Yus, great
Steve,
chatting.
a real pleasure. I
Until
look
next
forward to
time.
the next time, and I'll see you later on Teckel Talk.
All right. Bye.
Bye.